Okay, so when you've got used to logs and you're happy with undoing equations, so for example, 3 to the x is 7, x is log to base 3 of 7, or log to base 2 of x is 9, and then x is 2 to the power of 9. Once you're happy with that, then obviously we're cruel and we massively overcomplicate it by giving you some equations to learn. So, we've got 2 useful facts and I think 4 equations to learn, and they are quite difficult, but it'll be okay. So, useful facts to learn. Log to base x of 1 is 0. That means that whenever we have any base at all, if we're doing a log of 1, it's going to be 0. And the reason for that, let's just have a look at this equation and do x to the power of to both sides. Well, that's true, isn't it? Yeah. We already know that. X to the power of 0 is 1. Anything to the naught is 1. So if we do log to base x to both sides, we get useful fact number 1. Similarly, let's do it in the other direction this time. We know that anything to the power of 1 is itself. So if I do log to base x to both sides, then I get that. So it's a useful fact to remember. A couple of useful facts, same as indices. Same as indices again, some of the formulae just almost directly what you've learned at indices. So you know x to the a times x to the b is x to the a plus b. And what you're going to learn now is that log of ab is log of a plus log of b. Most common thing that I have to try to stop students doing is this. Students desperately want this to be true. Okay, not true. No, no, no. Do not do this. Loads of you are going to do this, but just, yeah. I should make a really bad punishment for this. Do not do this. This is not true. Log a plus log b, log a plus b doesn't equal anything. It just is itself.
Still a log, yeah.
Log a plus log b is log ab, in the same way that x to the a plus b is x to the a times x to the b, in the same way. Okay? Next one. Very similar. X to the a divided by x to the b is x to the a minus b. Log a over b, log a minus log b. So if you have an equation that says log x minus 1 minus log x is 2, then you can rewrite it as log x minus 1 over x is 2. So log a minus log b is log a over b. The only thing to point out with these formulas is that the bases do have to match up. So it doesn't matter what this base is, so long as they're the same there and there. And the same with the addition one. This base must be the same as this base in order to create that base there. Okay, so that's 2 of your formulae. Got useful facts. Useful fact 1, useful fact 2. Formula 1, log AB is log A plus log B. Formula 2, log A over B is log A minus log B. And then this one, everyone loves this one. This one, and you might be looking at it now and thinking, I don't know why, but this turns out to be everyone's favourite. So what this rule says is that if we have, for example, log to base 4 of x squared, then what you can do is get this 2 and put it down there and make it into a times 2. Ta-da! Or similarly the other way around. If there's a 2 there and you don't want it there, you can, ooh, I don't know what I did to that 2 there, it doesn't even look like a 2 anymore. You can shrink it down and make it a squared. So it's a nice little rule, and it's useful, for example, if we had 2 log x, log to base 3 of x, plus log to base 3 of x plus 2. And we think, oh, that's good. I want to use that rule, log a plus log b is log ab. But the rule doesn't have any numbers there. The rule requires this to just be blank, just to be a 1. So we've got a bit of an issue here with our 2, but hooray, we can move it up there. So we can say, well, that's okay, I'll make it into this.
Yep.
And now my bases are both 3, and I can put it together and make log base 3 of x squared times x plus 2. So it's a really nice simple rule, this one. This can come down the front. Everybody likes that one. Last rule, change of base. Not so pretty, but useful. If I've got a situation where my bases don't match up, log to base 3 of x plus log to base 9 of x plus 1, I can't use the rule. My bases don't match. I need to change the base. So here's how we change the base. I'm going to change my 9 to a 3. What you do is you draw a fraction line. You write log on the top and you write log on the bottom. Okay, that's the first thing. So we draw a fraction line. We write log on the top and we write log on the bottom. Okay?
Yeah.
Now we introduce our new base, which is whatever we want. Literally anything. Anything at all. Obviously in this case I'm going with 3 because I want to match up. So I'm going to have a 3.
Yep.
Okay? Now what was inside the log there, that's on the top. Okay? So in my case that was x plus 1. That goes on the top. And the old base, what was down here, that goes there. So in my case, 9. Exactly. Now actually, I can do something a bit clever with this log to base 3 of 9. This is super clever. I'm going to write it like this.
Yep.
Do you agree with that?
I do agree with that.
Then I'm going to move that down. Now what's log to base 3 of 3? 1, because log to base anything of itself is 1. So this is just a 2. So actually that's just a 2 down there. So it's nice, once you get more confident you can fiddle around a lot with it. Okay? So, here's some examples, but these are really hard. We're going to do these in another video, but pause this video now, see how many of them you can even start, then move on to the next video and have a look at the solutions.